An analyst predicts that an increasing in advertising spending will attract new users according to the following formula. If n is the number of new users per day and x is advertising dollars in millions, then n of x is the natural log of the square root of a million x to the fifth. How much should the company spend on advertising? Here's a rough picture of logarithmic growth. Y looks like n to the x. And this gives us a good picture of diminishing returns, where the function continues to grow, but slower and slower. Look at the difference between n of 1 and n of 2 versus the difference between n of 3 and n of 4. The derivative, n prime, gives us a formula for the slope of this function, for the rate of change. So the IRC, the instantaneous rate of change of n, at some x value x equals a, is exactly the derivative n prime with a plugged in. So back to that example. We need to find the derivative of n, which is giving the logarithmic growth. A little algebra will help us do this more easily. So here's our function. And we can use properties of exponents and logs to rewrite it in a less complicated way. Since the square root is the same as to the 1/2. And then we can use this property of logs to pull out the exponent. And then the addition property of logs to change the natural log of a million x to the natural log of a million plus the natural log of x. This will make the derivative much easier to find. Okay, so let's take the derivative. First thing, let's pull out the constant factor of 5/2. And then we'll use the addition property to distribute the derivative operator. So that's 5/2 times, in parentheses, the derivative of natural log of a million plus the derivative of natural log of x. So get that 5/2 out there. Now the natural log of a million is a constant, so its derivative is 0. And the derivative of natural log of x is 1/x. So the slope is given by 5/2x. The slope is 5/2x, or 2.5 times 1/x. What happens when x gets large? So you got 2.5 times tiny, tiny numbers, so that goes to 0. Which makes sense for diminishing returns. The growth stays positive, but it grows slower and slower. The growth goes to 0. All right, how fast is it growing at x equals 1/2? So that's 1/2 million budget. So just plugging that into the expression, we get that the rate of change is 5. So what does this measure? What is it that's changing? This is a measure of how quickly we get the change in new users per day divided by the change in money spent on the advertising budget. When does that rate of change slow down to 1? Well, at x is 2.5, so 2.5 million. That is, once the advertising budget reaches 2.5 million, it looks like we'd be gaining an extra 1 or rather, it looks like it would take approximately 1 more million added to the budget to get an extra 1 user per day. So did we answer the original question? Like, how much should they advance the advertising budget to? Not really. But we can at least tell them when they're getting more bang for their buck and when they're getting less bang for their buck by using the derivative to approximate how fast the new users per day is growing.